All right, you guys. So let's move on. Dog is dying of thirst over here. 22. Write each of the following expressions in the form C, A to the P, B to the Q. So it wants C, P, and Q to all be numbers, and it wants us to write some variables with exponents. So what does that look like? And this must be all over B, right? So 2a squared cubed is really 2a squared times 2a squared times 2a squared, which is really 8a to the sixth power, right? So 8a to the sixth power over b. You could have used that shortcut where 2 cubed is 8 and a squared cubed the power to a power, multiply the 2 and the 3, and that's where we got a to the sixth. But it looks like it does not want to have a denominator, right? Nothing here has a denominator, so we keep 8a to the sixth power. And remember, if we want to bring b up to the numerator, then we just need to make it to a negative exponent. So that was really b to the first power, so we make it b to the negative 1 power. Okay, 9ab, 9 times a times b cubed to the square root of, okay, but it wants us obviously to not have a square root. So what does that look like? What that really is the square root of 9 is really 3, right? So let's just take that out. This is really 3 times the square root of ab cubed. Okay, ab cubed is really the square root of a times b squared, right? Why did I do it that way? Because I know that b squared, the square root of b squared is just b. So actually this is the same as 3b times the square root of a times b. Okay, and we really can't reduce that anymore, except it wants us to write it in the where we just have exponents and we aren't using radicals. So remember, the square root of something is really that thing to the half power. So this is equal to 3 times b times a to the 1/2 power times b to the 1/2 power. And then lastly here, you guys, we can still multiply these two b's together. And what happens when you multiply the same base of the exponents? You just add the exponents. So let's just start putting things in alphabetical order. So we have 3, a to the 1/2, and then if we combine those b's, it's b. This is really b to the 1 power. This is really b to the 1/2 power. So that becomes b to the 1.5 power. But we want to write 1.5 as just one fraction, which would just be 3 halves. So this would be b to the 3 halves power. I don't know if that made that easier or not. Sometimes you don't know unless you're working on a problem. And you realize if you do change things around to be like this, it might match something else or cancel something out, right? Okay, what about this next one? Well, I have a times 2 over b and divided by 3 over a. Okay, a times 2 over b is really, if we multiply that out, 2a over b. And if I'm dividing something, I'm going to change it to multiply, and I'm going to flip this over. So I'm actually multiplying that times a over 3. Now that I'm multiplying, I just multiply the numerator. So 2a times a is 2a squared over 3 times b is 3b. Okay, and like I said, it wants c to be a number. Well, 2 over 3 is really just a number that's called 2/3. It's not a whole number. Okay, and then we have times a squared times b to the negative 1 power. Remember, b was on this denominator here, so we need to make it to the negative 1 power. And the reason we didn't have to do anything to the 3 is because actually we just kept 3 on the denominator. We just made it part of this number here. Okay. What's next? What's next? Oh, more fun. More fun with fractions, you guys. Okay, I see something. I see something here. On the numerator here, I'm going to factor out an a because there's an a here and there's an a here. So if I factor out an a, I have b minus 1, right? A times b would be ab. A times negative 1 would be negative a. Now, on the denominator, I'm going to factor out a b. Word. And then I have, guess what, you guys? B minus 1 left over. Because b times b is b squared, and b times negative 1 is negative b. So those cancel. Okay, but remember, it wants everything on the numerator. So we have a, that stays the same, and then we just make b to the negative 1. Cool, cool. All right, all right. What do we have next? Let's do this. We have a to the first power divided by b to the first power times the square root of a. All right, well, we can do this. Let's just move everything to the numerator first, too. Well, okay, let's do this first. Let's change the square root of a to be a to the 1/2 power. And then let's move everything to the numerator. So a to the first power is just a. If we move b up to the numerator, it's b to the negative 1 power. And if we move a to the 1/2 power up, it is a to the negative 1/2 power. Cool. But I can multiply this a times this a because they have the same base, and all I have to do is add the exponents. So a to the first power times a to the negative 1/2 power is really a to just the 1/2 power, because 1 minus 1/2 is just 1/2, and b to the negative 1 power. Cool. And just remember, it wants us to write it like this, but this would really be the square root of a there if we wanted to make that the square root of a. Okay, this next one looks ugly, but I'm wondering if there's some easy ways to cancel stuff out before we get started. Let's go ahead and take the powers to the power. So if we look at this first fraction here, power to a power means I multiply those exponents. So instead of a to the 2/3, that really becomes a to the 4/3. And I have to do the same on the denominator. This really becomes a b. 2 times 1/2 is just 1, right? Cool. Times b to the 2/3 power over a to the 1/2 power. Okay, we're just multiplying all of these, so let's just throw these two up on the numerator. All that's going to happen is we turn them into negatives, right? So, and then I'm just going to put the a's together. So I have a to the 4/3 times a to the negative 1/2 times b to the 2/3 times b to the negative 1. And when we multiply the same base, all we have to do are add the fractions together. So this is going to be a 4/3 minus 1/2. Oh, you guys are going to have to check. I'm going to pause this and do it so that I don't waste any minutes here. All right, I got a to the 5/6 power times b to the negative 1/3 power. Cool. Double check that if you would like, the adding fractions. All right, finding inverse functions. There are 3 steps to finding inverse functions. Write these steps down really quickly if you don't remember them. It is 1, rewrite f of x as y. 2, switch places with x and y. Switch x and y. And 3, solve for y. Write those down, learn them. This first one, is it 2x plus 3? I hope so, because that's how I'm going to do it. But if it's minus, you guys can figure that out. So rewrite f of x as y. So this is really y equals 2x plus 3. Step 2, switch x and y. This is really x equals 2y plus 3. Solve for y. I'm going to subtract 3 from both sides. X minus 3 equals 2y. Then divide both sides by 2 to get y by itself. And I get y equals x minus 3, that whole thing over 2. Let's not make more work for ourselves, you guys, by trying to like find common denominators or fractions, like whatever. This is fine. X minus 3 over 2. Okay? All right. Next one. All right. Let's see how many I can do before my 15 minutes is up. Per video. I'm on the free video, so I only get 15 minutes. So next one, y equals x plus 2 over 5x minus 1. Well, that is really, we switch our x and our y. X equals y plus, and you know what, you guys, just for fun, I'm going to switch sides too. So y plus 2 over 5x minus 1 equals x. I just switched sides because I think from left to right, because I grew up reading and writing that way. Now, oops, look, I didn't change this. This needs to be a y also. Okay, so how am I going to solve this? I'm going to cross multiply. So I have x times 5y minus 1. I'm trying to get y by itself is equal to y plus 2. And then this ends up being, all right, you guys, now I'm going to distribute this x here and here. And that's going to give me 5xy minus x equals y plus 2. Now let's get everything with a y on the same side and everything and the other stuff on the other side. So I'm going to subtract y from both sides, and I'm going to add an x to both sides. So that gives me 5xy minus y equals, right, and then these x's cancel out, equals x plus 2. Almost there. Now on this side over here, I'm going to factor out a y, and that's how I'm going to get it by itself, right? I'm going to take this, I'm going to take a y out, and that leaves me with 5x minus 1. So y times 5x minus 1 equals x plus 2. Then to get y by itself, I just divide both sides by 5x minus 1. So y equals x plus 2 over 5x minus 1. Okay, don't make it any harder, just leave it like this. That's the inverse. And I guess technically you should write it as f prime of x. Instead of leaving it as y is equals, we're going to write it as f prime of x. That means the inverse of our original f of x is equal to what we just figured out. All right, and it looks like we have one more. Hopefully I can get through it before the end of my 15 minutes is up. All right, you guys, this is going to be a little bit tricky, but what we're going to do is complete the square that you may remember from last year. So, like I said, I like to put my y's on this side. I'm going to do y plus 2y, but I'm going to add 1 to the other side. I'm going to put that on the other side is equal to x plus 1. And now I'm going to complete the square. I'm going to take here, I'm going to take half of 2 and square it, right? Half of 2 is 1. 1 squared is 1. So actually I'm going to change this side to be y squared plus 2y plus 1. Okay, so basically all I've done is I've added that 1. And what you do to one side, you have to do the other side, right? So here I'm going to put x plus, instead of x plus 1, I'm going to add that extra 1, x plus 2. Okay, why am I doing this? It'll make sense in just a second. So now that this is a perfect square, this is actually the same as y plus 1 squared will give us y squared plus 2y plus 1 is equal to x plus 2. Now I can take the square root of both sides. So I get y plus 1 is equal to the square root of x plus 2. Now I just subtract 1 from each side, right? So the inverse of this, the inverse of this 1 is really f inverse of x, don't forget that little inverse sign, is equal to the square root of x plus 2 and then plus 1, minus 1 on the outside. And that's the inverse there.